Okay, today I'm going to be showing how to do a thermal analysis in Abacus. So what I have set up so far is I've created the parts, I've assigned materials, and I've placed them into the assembly. So it's important that when you are setting up your materials, that you have your density, specific heat, and conductivity, all important things when you're doing a heat transfer analysis. So in this situation, we are modeling a can filled with a liquid, in this case water, and it's going to be placed from room temperature about 20 degrees Celsius into a freezer about minus 18 degrees Celsius, and we're going to see how long it takes to reach a satisfactory level of cool. So after we have the assembly, the next thing that we're going to move on to is a step. So this one's pretty self-explanatory. We're not doing anything static. It's a heat transfer. So click heat transfer, hit continue. So in this case, we're not going to do steady state. We're going to do transient so that we can see at what time we reach a certain temperature. These are ran in seconds. So I would like to go up to an hour. I wouldn't want to wait longer than an hour if I'm throwing it in the freezer. And then I'm going to have it jump every 15 seconds. And I'll let it go up to just an arbitrary number here. Okay, so now that we have our heat transfer, let's rename that. So moving off to the step, we're going to create our interaction. So this is where our heat transfer is actually happening. Our first one that we're going to do is going to be our convection. So convection, and that's going to be under surface film condition. So in the surface film condition, you have to pick which object and which surface you are pushing heat out of. So go to assembly. I like to hide the parts that aren't going to be convecting heat. So we select our can. We want to make sure that we are choosing the outside. In this case, it is the brown and the purple is on the inside. So the film coefficient is going to be your heat convection coefficient, 30, and then our sink temperature is the ambient temperature. So in the freezer, it's minus 18 degrees Celsius. Okay. So the next thing we're going to do is do our conduction between the can and the water. So we go back to our interactions. Conduction. This happens at surface-to-surface contact, so we choose surface-to-surface contact. For our first, again, I'm going to start with the water. Select all the surfaces of the water. The second type, it's going to be a surface. Show the can, hide the water. And it's going to be on the inside, so purple. Okay, so then you get this screen popped up here. So because it is a liquid that we are modeling, we want it to be in contact with the other surface. So how we adjust our settings, because we have two solid pieces in our parts, is to allow it to remove the overclosure. So click here and it forces them together. Now, when you're doing conduction, you're going to need to add a property. Click the button here. It's going to be a contact and we'll label it conduction. Again, we're doing a thermal analysis, thermal conductance. So this clearance is saying when it's touching, what do you want it to be? So we'll label it at the aluminum. And then it's 0 when it's pulled so far away. So we set it that it's touching, but if the water for some weird reason is 10 centimeters away, it's not conducting heat. Okay, so now we have conduction finished. Next, we are going to go to the top of our model. And if we were doing radiation, this would be important. Is you would edit your attributes and you would adjust your absolute 0 and your Stefan Boltzmann constant. If you don't do this, then it'll shoot errors out when you do radiation. In this case, we're not going to go over it, but if you do radiation and you see that you're having these errors, it's because you haven't adjusted this. Okay, so going back down. So within a thermal analysis, in order to establish initial temperatures, you can't set it as a boundary condition. Boundary conditions can only be marked as 0 at the initial step. So instead, you have to do a predefined field. It's heat transfer. We set it at the initial step and then temperature. So I would like to do the can first. So I'll come up here, light the water, select the can. So we were saying that the temperature that we average room temperature is about 20 degrees Celsius. And then we're going to repeat the same thing for the water. So okay, and now we are ready to run our analysis. We need to mesh it. So I have the mesh already loaded in. I used wedges to model this one. When you go through, you have to choose an element type of heat transfer and then the correct geometry here. So if it's not heat transfer, it won't mesh properly. So after we've meshed, we move to the job. Let's create the job. We'll call this heat. Sure it matches with the model. So we have the job and let's submit it. This is asking about a history output. It's not necessary to go change it. Okay, let's see what we got. Nope, we're looking at heat. Let's start with temperature. And what we want to do is cut the object in half. Let's look at it from here. So starting at our beginning, we have everything is at 20 degrees. And as time goes through, we can see that it's cooling down